Welcome to Study Loop.
All right. So for this problem, we have a PV diagram, and we know the amount of gas, which is 0.0175 moles. And so the first part, we want to figure out which state has the lowest temperature. To do that, so this is part A. To do that, we need to utilize the relation PV equal to MRT. And we already know the pressure and the volume at each state, A, B, C, and also we know the N and R is a constant. So basically, we can just do the calculation for temperature for each state. So T equal to PV over N times R. Okay. And before you do that, you need to transfer the unit like this 1 atmosphere into Pascal, and transfer this this liter into meter to the cube. Meter to the cube. Yeah. And so the unit transfer relation is 1 atm is 101.325 Pascal. And the 1 liter is 10 to the -3 meters cubed. Okay. And you simply just plug in this, read this, the value, read the coordinates. Like for state A, P is 0.2 or 0.2 atmosphere, and the V is 2 liters. You just read these values and plug in the relations. And after you have done this unit transfer, you can just do the calculation simply. So the one I found is the temperature at state A is 278.6 Kelvin. Yeah. The result you obtain from this formula is directly has the unit Kelvin. Okay. The Kelvin is a standard unit. PV is calculated to be 696.4 Kelvin. And PC is 1253.5 Kelvin. So clearly the PA is the lowest. Okay, so this is part A. And for part B, we want to figure out the work done in each process, theta B and beta C. As you can see that the process from A to B, the volume is not changing. So basically, the work is simply 0. So work is 0 because the volume is not changing. Okay. And the work done for process B to C is we need to utilize this relation, the work equal to integral P dV. So this is the definition of work done by the gas. Okay. And as you can see that for the process B to C, P is a function of V. It's not constant. And this integral simply represents the area below this line, below the busy line. Okay. This is the meaning of this integral. So one way is just you can plug in the relation between V to this integral and then do this integral completely. And the other way is just you just use simple mass and count the area below this line. Okay. And I'll just tell you the result directly. The area, the shaded area is 162.12 joules. Yeah, and also bear in mind that before you start doing this calculation, before we start counting the area, you need to transfer the unit into the standard unit. This atmosphere to Pascal, and this liter to meters cubed. Okay. This is PC, the work process. part C, uh, we need to utilize the first thermal law, which is the work equal to heat into the system minus delta U, where delta U is the change of internal energy. So delta U is given as Q minus W. And so we see that Q is 215 joules, and the work in the total process is simply 162.12 joules. This one plus this one, but this one 0, right? So total work is simply 162.12 joules. So you simply need to use this number minus this number, and you obtain the change of internal energy. And the final result I found is 52.88 joules. Okay, all right, that's it.